There was a time. No. Small matter. Time matter starts with an explanation why Big Bang and universe expansion is not required to explain redness of all remote stars and galaxies in our universe. Redness of the distant universe was first observed by an astronomer Hubble about a century ago, and the even more distant universe looked empty to a naked eye. Hubble interpolated his measurements of redness, which he called redshift Z, and found that it is proportional to the time it takes for a light emitted by a distant star or galaxy to reach our eye. Z equals h0 times t, where h0 is a constant named after Hubble. It is very small number inverse to the number of seconds in 14 billion years. T is time for light to reach us. When stars are local/close to us and t is small, then z equals 0, no redshift observed, meaning we see local stars and galaxies in their natural colors. When t equals 14 billion years, h0 times t equals 1 and z equals 1, meaning natural colors shift to infrared, which is invisible to our eye. Now, to the most interesting part. A long time ago, time in our universe ran slower than it runs now, and that actually explains the redshift, redness of the old universe, as we see it. Humor me. Let's say, 10 billion years ago you started sending letters to yourself, 1 letter a day. 10 billion years have passed, and now, for some reason, our day is twice shorter/faster than it used to be, and letters start coming. How many letters you'll be receiving a day? Answer: 1 letter every other day, as days pass faster than letters come. Frequency of receiving letters a day dropped twice compared to letters sending per day frequency. And if 14 billion years ago time was twice slower than today, then of 100 light waves sent a second, you'll be receiving 50 light waves a second now. Light frequency drop is called redshift. It is the same as wavelength increase. Wavelength is inverse to frequency. Let's denote by d slowness of time. D equals 2 stands for twice slower time 14 billion years ago. D equals 1 stands for the same/current time. We just have explained how redshift and slowness of time are related. Z equals d, 1 or d equals z plus 1. Slowness of time was called time dilation by Einstein. Astronomers in the James Webb Telescope recently discovered highly redshifted galaxies, with redshift values between 16 and 20. Time in the universe was 17 to 21 times slower then. Read chapters 5 in Time Matters about the early times, when time was extremely slow, even slower than observed in James Webb. There was no, or almost no, matter and no universes, only space and time. Chapter 11 explains that time burns into matter/antimatter/light, and chapter 5 explains how this burning residue collects into universes in areas of slower time. P.S. Let me finish with an opening episode from Lucky Number 11 having the same punchline as our story. There was a time, no small matter. P.S. Next time speeds up in the universe. By what formula? Time speeds up in the universe. By what formula? How come that time was twice slower 14 billion years ago, 12 times slower 32 billion years ago, and so forth, but there is no math formula for time, or time dilation, derived from these measurements. Let's denote by t how much of our time passed between some moment in the past and now, and let's try to find formula dt for time dilation at some point in the past. dt stands for how many seconds of our time passes for 1 second of the time that was t time ago. For example, d 14 billion years equals 2, meaning 2 our seconds pass for 1 second of the 14 billion year old time. d 32 billion years equals 12, meaning 12 our seconds pass for 1 second of the 32 billion year old time. Let's denote by tau time local to the past, local to 32 billion years ago, local to 12 billion years ago, and by delta we denote small interval in time. For 1 second of the past time tau, dt seconds of our time pass. Delta tau equals dt delta t, just comparing number of past and current seconds. Delta t equals 1/dt delta tau. Let's run total over the last formula. Delta t equals 1/dt delta tau. Left side total is our time actually. Delta t equals t. On the right side we have two variables t and tau. We can get rid of tau by replacing delta tau term with dt delta t. 1/dt delta tau equals 1/dt dt delta t equals 1 delta t. All the above in a single line. T equals delta t equals 1/dt delta tau equals 1/dt dt delta t equals 1 delta t. The last one is just an integral of 1 from 0 to t, 1 dt. Thus, the line above comes 2. That explains why practically any function dt can describe time dilation, and why no math formula for time is derived from Hubble measurements. Time dilation dt value only depends on how much time was burnt into matter between t time ago and now. Check explanation in burning time in labs and in galaxies. And there is neither reason nor data for that burning going at a constant, exponential or logarithmic pace. P.S. Hubble's law dt equals 1 plus h0 times t is just a linear, first order, approximation, and not a real formula.